Mining the moon.
Sounds like science fiction.
Kinda is, but kinda isn't.
No, it's a real thing.
Scientists are researching it.
Companies too.
Even a startup wants to mine the moon for this stuff.
A lot to unpack.
Well, let's start with helium-3.
Okay. Helium-3, it's a type of helium.
The stuff in balloons.
Right, but it's an isotope. So like most helium,
Mm.
it has 2 protons,
Okay.
2 neutrons.
Okay.
But helium-3 only has 1 neutron.
1 neutron.
Yeah.
So that makes it rare.
Super rare, especially on Earth.
Where do we even get it now?
Tiny amounts from nuclear weapons tests,
Oh, wow.
radioactive decay.
Not exactly ideal.
No, not at all.
So the moon is better.
Way better.
How so?
It's like a giant helium-3 reserve. Think about it. The Earth has this atmosphere.
Protects us.
Right. But it blocks the solar wind, which carries helium-3.
Okay.
But the moon, no atmosphere.
Right.
Been bombarded by the solar wind for billions of years.
So the moon's surface is full of helium-3.
Pretty much.
And that surface is called...
regolith,
Like-
that loose, dusty layer.
Okay.
Top few meters of that.
Okay.
Scientists think there's at least 1 million tons of helium-3 there.
1 million tons.
At least.
Wow. Okay, so big question.
What is it?
Why is helium-3 so valuable?
Why is it better than regular helium?
Right, exactly.
Fusion power. A clean, safe energy.
Okay.
Almost limitless.
Limitless. Okay, hold on.
It's the promise of helium-3.
That sounds amazing. But
Martin.
isn't fusion power still theoretical?
Mostly, yeah.
So we're talking about mining the moon for fuel
Yeah.
to power something that doesn't even exist yet?
Well, not on a large scale.
Okay.
So they are working on it. Get the Princeton Plasma Physics Laboratory.
What are they doing?
Researching fusion.
What kind?
It focuses on fusing 2 types of hydrogen, deuterium and tritium.
Okay.
But there's a problem.
What's that?
It produces a lot of radiation.
That's not good.
No, specifically neutrons.
So helium-3 would fix that.
Yeah, fusion reactors that use helium-3,
Uh-huh.
they'd produce way fewer neutrons. Yeah,
Safer.
much safer.
Potentially more efficient, too.
Could be, yes.
That's incredible.
It is.
So we have this idea.
We do.
We have the technology,
In theory.
but how do we actually mine it?
Mine helium-3 on the moon.
Yeah, it's not like we can just send people up there with shovels.
No shovels.
So what do?
We need special equipment.
Okay.
A plan.
Like what?
Well, FTI has some ideas.
FTI.
The Fusion Technology Institute
Yeah. Where's that?
at the University of Wisconsin.
Okay. I've heard of them.
They've been researching this for decades.
Lunar mining? So what's their plan?
Well, one idea
Yeah.
is the Mark III miner, or M3.
Sounds impressive.
It is, imagine this combine harvester,
Okay.
but way bigger.
Okay.
This M3,
Uh-huh.
it scoops up tons of lunar regolith.
That's surface stuff.
Yeah, using a giant bucket wheel.
What-
Regolith goes into a heater, powered by a massive solar concentrator.
Solar-powered mining on the moon.
Makes sense, right?
Tons of sunlight.
Exactly.
So how hot does it get?
Over 700 degrees Celsius.
700 degrees. Wow.
Yeah, hot enough to release the trapped gases.
Including helium-3.
Exactly.
Okay, so I'm picturing all this helium-3 just floating away.
No, they thought of that.
Okay.
The design,
Yeah.
it includes a system to separate the helium-3.
From the other gases.
Right. They estimate
What?
that the M3 could get 66 kilograms of helium-3 per year.
66 kilograms? That doesn't sound like a lot.
It's more than you think.
Right.
1 ton of helium-3
Yeah.
could power a city the size of Dallas for a year.
A whole year with just 1 ton.
Now, 1 ton.
That's insane.
It is.
Okay, so big idea.
Huge,
We have the technology in theory,
in theory.
but realistically, is this going to happen?
It's a challenge.
What's the biggest challenge?
The scale. We're talking enormous amounts of regolith.
The M3 would handle how much?
Over 550 tons every hour during the lunar day.
Wow. And then we got to get it back to Earth.
That's another challenge.
Transportation.
Big one.
Expensive.
Very. So we're a ways off.
Maybe not as far as you think.
What do you mean?
Technology is advancing,
Okay.
and there are people
Uh-huh.
who are determined to make this happen.
Like-
So there's a startup called Interloon.
Founded by former Blue Origin employees.
Serious people.
Yeah, and they just got funding.
$15 million.
So what's the plan?
First step is a demonstration mission.
To the moon.
When?
2026?
Not soon.
It is.
What will they do?
Sample regolith,
Oh.
measure the helium-3,
Okay.
and test their extraction tech.
All on the moon.
On the moon.
So like a trial run.
Yeah, prove it can work.
Make sense?
If it works,
Uh-huh.
They want to build a pilot plant by 2028.
On the moon.
Yep, small scale.
To refine the process.
And start producing helium-3.
That's ambitious.
And then by 2030, full-scale mining.
You're moving fast.
They are.
Okay, so we've talked about fusion power.
Uh-huh.
But what else can we use helium-3 for?
That's a great question.
Is it all about fusion?
Not just fusion.
What else then?
There are other uses driving demand right now.
Like what?
Well, one area is superconducting quantum computing. Needs super low temperatures.
Okay.
And guess what?
What?
Helium-3 is essential for that.
Wow, so it's not just about future energy then.
Nope.
It's helping us advance technology right now.
That's right.
That's really cool.
And there's more.
Yeah.
In the medical field.
Okay, what is it? MRI?
You mean those big machines?
The ones that see inside the body?
Yeah.
Helium-3 can make those scans clearer.
How?
By creating special gases.
For the MRI.
Right, especially for lung imaging.
Interesting.
Growing market for helium-3.
So even if fusion takes a while, lunar helium-3 could still have a big impact.
Very soon.
On technology.
And healthcare.
And healthcare.
So now I'm curious.
About what?
About the economics of this. How much is helium-3 worth?
Well, remember how rare it is?
Yeah.
Right now, 1 liter costs thousands of dollars.
Seriously? Yeah.
So would lunar mining be profitable?
That's the question.
It's expensive to get to the moon. Extract the helium-3. Bring it back.
It all adds up.
But if the price is high enough,
Could be very profitable.
that's what Ingerland is betting on.
Big gamble.
But could change everything.
Energy, space exploration.
Maybe even humanity's future.
Maybe. But there's something else to consider.
What's that?
Ethics. And legal stuff.
It is.
Who owns the moon?
And all its resources.
Yeah, it's like uncharted territory.
Kinda, yeah.
So what are the rules?
Space law. It's a bit of a Wild West out there.
Makes sense. It's pretty new.
Relatively, yeah.
What's the main thing we have?
The Outer Space Treaty?
When was that written?
1967.
That's before we even landed on the moon.
It is.
Seems like it needs an update. Especially for something like lunar mining.
Yeah, there have been some attempts to modernize it.
That's tough.
But the Outer Space Treaty,
Yes.
it does have some basic principles.
Okay, like what?
Well, one big one is that space belongs to all humankind.
So no one country can claim it.
Right. No planting a flag and saying the moon is mine.
No lunar land grabs?
Exactly.
So anyone can just go mine helium-3.
Not so fast.
What do you mean?
The treaty,
Uh-huh.
it says countries can't claim ownership,
Okay.
but it doesn't say anything about commercial activities,
Like mining.
like mining.
So it's a gray area.
A big one.
So what does that mean for companies like Interloon?
It means there's a lot of uncertainty.
So they could just go for it.
But they have to be careful.
How so?
The Outer Space Treaty.
Right.
It also says
Uh-huh.
that activities in space,
Yeah.
they should benefit all countries and respect everyone's interests.
So not just a free-for-all.
No, not at all.
Sounds like we need some kind of international agreement.
On how we manage these resources.
Because the moon,
Yeah.
it belongs to everyone.
In theory, yes.
But someone's going to get there first. Start mining.
And then what?
Who gets the profits?
That's the question.
Do they get to keep it all?
Some people think so.
Others disagree.
They say the benefits should be shared
Share how?
among all countries.
Even the ones that can't afford to go to the moon.
That's the idea.
That's a tough one.
It is.
So we have a potential legal battle brewing.
It's possible.
And on top of that,
Yeah.
we have to think about the environment.
The lunar environment.
Right. We can't just trash the moon.
No. We have to be careful.
We've already messed up Earth pretty bad.
It's true.
So how do we mine the moon responsibly?
Very complicated.
We're talking about a whole new frontier.
A new era of space exploration.
With new challenges.
And new rewards.
We need to approach this carefully.
Responsibly.
So for our listener,
Yes.
why should they care about lunar helium-3?
Why does this matter to them?
Right. It seems far away.
It does.
But it could have a big impact.
On everyone.
How so?
Well, think about the energy crisis.
Fossil fuels are polluting the planet.
And causing climate change.
So helium-3 could be the answer.
It could be.
Clean, safe energy.
Limitless energy.
It sounds too good to be true.
It does.
But it's worth exploring.
Absolutely.
Even if it takes a while.
Even if we never actually mine it.
What do you mean?
The research itself,
Yeah.
it's pushing the boundaries of science and technology
So we're learning new things
all the time.
that could benefit us in other ways.
Exactly.
Like what?
Robotics, material science, space travel.
So the benefits go beyond just helium-3.
They do.
And then there's the economic impact.
Jobs, investment, a whole new industry.
A lunar economy.
It's possible.
But we have to be careful.
About the ethics.
And the legal stuff.
We don't want to repeat the mistakes of the past.
Exploitation, environmental damage.
We need to be better this time. So for our listener,
yes,
what's the key takeaway?
Lunar helium-3 mining.
Yeah.
It's a crossroads for humanity. A chance to rethink our relationship with energy.
With space.
With each other.
It's a big deal.
If helium-3 mining becomes a reality,
Okay.
who should own those resources?
The companies that mine them?
Maybe.
Or should be shared?
With all of humanity.
It's also rich in other resources.
Okay, like what?
Things that could be super important for us.
Like what kinds of things?
Things like water ice.
Water ice on the moon?
Yeah, and rare earth elements.
What are those?
They're used in all sorts of tech.
Our phones and computers.
Exactly.
Wow.
And even precious metals like platinum.
Platinum on the moon?
Yep.
So we're talking about a whole new era then.
Of space exploration.
Driven by all these resources.
It's like a new gold rush.
A lunar gold rush.
Exactly.
That's a great way to put it.
And as we learn how to mine helium-3,
yeah,
we'll gain knowledge
okay.
that we can use for other resources too.
So helium-3 is just the beginning.
It's a stepping stone.
To something much bigger. It's hard to wrap my head around all this.
It is a lot to take in.
We're talking about a whole new way of thinking about space.
It's not just about going there anymore.
It's about staying there.
Building a presence.
Maybe even living there.
It's possible.
It's pretty incredible.
It is.
And a little bit scary, too.
It is a big undertaking.
But it's also exciting.
Oh, absolutely.
It shows what we're capable of.
Human ingenuity.
Our drive to explore.
Push the boundaries.
It's in our nature.
It seems to be.
And who knows what else is out there. Well, we've covered a lot of ground today.
We have.
All about lunar helium-3.
And its potential.
We talked about the science.
The technology.
The economics.
And the rewards.
It's a complex issue.
But one that's worth exploring.
If you're interested in learning more.
Yeah, we encourage you to check out the resources we mentioned.
The Fusion Technology Institute.
Interloon.
And all the latest developments in space law.
It's a rapidly changing field.
Keep learning, keep exploring, and we all have a role to play.
The future of space is our future.
Until then, keep looking up.
And keep asking questions.
Because the future is out there waiting for us.